Assalamualaikum and hi. Today we are going to learn about chapter 1 partial differentiation. But first of all, you need to recall back all the rules of differentiation from previous semester. Okay, because we will use it again in this chapter. Okay, this chapter have 4 subtopics. 1.1 first order partial derivative, 1.2 second order partial derivative, 1.3 extremum of functions of two variables, and the last one 1.4 Lagrange multiplier. For lecture 1 of 3, we are going to focus on first order and second order partial derivative. Okay, let's look for the learning outcome. At the end of this lecture, okay, you should be able to compute the first order partial derivative involving two variables and also able to compute the second order partial derivative involving two variables. Okay, for introduction. Okay, when we are given the functions with single variable, such as fx equals to 3x squared plus x. Okay, we will get the derivative of f with respect to x. So we differentiate the function 3x squared plus x. Okay, so you should get 6x plus 1. Okay, when you differentiate each term. Okay, let's say, okay, fy equals to 4y squared minus y plus 1. We will get the derivative of f with respect to y. So in this case, okay, the function is, okay, in the term of y, okay, with variable y. So we differentiate, okay, for y squared, you differentiate, you get 8y. Negative y, you differentiate, you get negative 1. And constant 1, when you differentiate, you get 0. Okay, so the answer is 8y minus 1. So this example is with single variable. Okay, only one variable. However, okay, when we are given the multi-variable functions, that means more than one variables, such as fxy equals to x plus y squared and fxy equals to y exponent x minus x squared. Okay, this is the functions, okay, with two variables. Okay, we will get the partial derivative of f with respect to x or y. Okay, let's say, okay, for the first statement, for partial derivative of f with respect to x, we use, okay, this one is curly d, okay, or we call it, okay, delta f over delta x, okay, instead of dy dx. Okay, dy dx is only for one variable function. We may use the symbol f sub x. We can get the partial derivative of f with respect to x by differentiating f with respect to x and treating y as a constant. Okay, let's look for the second statement. For partial derivative of f with respect to y, okay, we use delta f over delta y. We also can use symbol f sub y. Okay, we can get the partial derivative of f with respect to y by differentiate f with respect to y and treating x as a constant. Now let's look the definition of partial differentiation. It is the process of finding derivative of several variables, okay, or multi-variables with respect to one of its variable. Okay, we only derive to one variable while keeping other variables fixed, okay, as a constant. Okay, 1.1 first order partial derivative. Consider a function z, okay, with two independent variables, okay, x and y. So we can write it as z equals to f xy with two variables. If we regard y as constant, okay, z is a function of x only. And the partial derivative of z with respect to x is, we can write it as delta z over delta x, okay, or delta f over delta x, or delta f xy over delta x, or f sub x, okay, bracket xy or f sub x. This bracket with x and y, okay, represent the okay, the point, okay, if we want to substitute later. If we regard x as constant, okay, z is a function of x only. Okay, and the partial derivative of z with respect to y is, okay, we can write it as delta z over delta y, delta f over delta y, delta fxy over delta y, f sub y xy, or f sub y. Differentiation y with respect to x or with respect to y. Okay, function f, okay, in two variables x and y. So fxy equals to x squared minus 3x plus y squared minus 3y plus 5xy. Okay, we want to differentiate. Okay, first we want to differentiate f with respect to x. So we keep y as a constant. So let's look for the function. Okay, which term has, okay, variable x. Okay, we have three terms. Okay, now we differentiate. Okay, x squared. Okay, you should get 2x. Okay, differentiate minus 3x, you get minus 3. Y squared minus 3y are constant. Okay, so when we differentiate, we'll get 0. So 5xy, first, okay, we write the constant 5y. Then we differentiate x, okay, the variable, you get 1. Don't forget to simplify. So 2x minus 3 plus 5y, okay, for your f sub x. Okay, so let's proceed to the second one. Differentiate f with respect to y. So keep x as a constant. There are three terms, okay, with y. We differentiate. So x squared minus 3x is a constant. Okay, so differentiate y squared, you get 2y minus 3 plus, okay, the constant is 5x. You differentiate y, you get 1. So your last answer should be 2y minus 3 plus 5x.